We are going to talk about the differentiation in terms of the del. So we have a question here. We want to show that the gradient of uv is equals to v del u plus u del v. And first of all, I will explain what this symbol means. This is called the del function. And the del function is defined as following. The del is actually the unit vector of x, partial differentiation of x plus the unit vector of y, d of dy, plus the unit vector of z, z direction of dz. So this is the operator, the del operator. So the del operator is one function. If you are going to del with a scalar, suppose this is a scalar, then this will become the gradient. It's called the gradient of phi, right? Because phi is a scalar. So it's going to be the gradient of phi. But if you are going to have the del dot v, and v is a vector, so it's going to be called the divergence of v, vector v. That's a vector here, a vector. And if we have got a del cross with v, v is the vector, this is going to be called the curl of v. V is also the vector, right? So the del and the curl, and we have defined it. So let's look at the gradient, because these are scalars of u and v. So the gradient of u and v can be written as the operator d of dx plus y d of dy plus z d of dz of what? Of the bracket u v, right? And if you look at uv, this looks like is a product. On differentiation, we use the product rule. Now, what does the product rule say? We won't go far from there, but we know it's a product. So first of all, can be separated. So what are we saying? We are saying we can say d of dx of uv plus the y vector, unity vector in the y direction, d of y of uv, plus I think I have got enough space. Let me just create it to look so nice. Okay, of uv plus z d of dz of uv. uv, this is scalars. Now using the product rule, rule, okay, it's another topic which you'll look at in other videos. Using the product rule, we are basically saying that we can take out the unity vector outside and say we have got, first of all, we are going to use u dv of dx plus v du of dx, close a bracket, plus we look in the y-axis, we are saying u dv of dx plus v du of dx. In the z-axis, so in the z-axis, we are going to say u dv of dx plus v du of dx. Right. So what we're going to do is now to split the x. So in the z-axis, we have got the u dv of dx. Plus, in the z-axis again, we have the v du of dx. Plus, in the y-axis, unity vector, u dv of dx. Plus, u again, it's du of dx. Now, in the z direction, z is u dv of d. Okay, sorry, I meant y here because we are in the z direction. So it should be y. So it's the z direction here, plus z is v du of dz. So after doing that, we are going to factor out. So in other words, we have to group. So group the v du of dx, and we group u dv of dx. Right? We group, and it can be x, y, z, also x, y, and z, like that. We are grouping. So this is just a way of explaining that we are going to group them. So how do we group them? We will say we are focusing on u. So looking at u dv of d, either x, y, or z. We are basically saying it's x here, bracket u dv of dx, plus y of u dv of dy, plus z u dv of dz. Plus, now we are grouping in terms of v du over either dx, y, and z. So we are saying it's going to be x. Okay, we write at the bottom. X here, it's v du over dx. Plus the y is going to be v du over dy. Plus z, it's v du over dz. Remember, it can confuse you, especially when you say x, coordinate x, it's dx. Coordinate y, it's dy. Coordinate z, it's dz. Coordinate x, you should be careful on that. Then after that, we will definitely, if you look very careful, we can take out the u outside from the first group there. So we take out the u and put a bracket. It will be x here, dv over dx, plus y dv over dy, plus z dv over dz. Right? We do the same thing. We take out the v here, and it will be x du over dx, plus y. Okay, it's not going to be good enough. It's going to be du over dy, plus z du over dz, like that. We close it. Now, after doing that, we will factor out the u outside. So u will factor out the v first one. It's going to be on the x direction, d of dx plus y d of dy plus the z d of dz. Then we take out v, it's out, plus, remember v is out, so it's going to be x d of dx plus y d of dy plus z d of dz. And we take out the u is outside. So basically, if you look very careful, it's going to be, this is now the operator, del operator. So it's going to be u, the del operator of v, plus v, the del operator of u. So we have proved that the gradient of uv is going to be like that. Please subscribe to my channel for more videos. I will put more videos for mathematics and honors level for physics. Thank you.